equation that contains a variable in the x. So for example, if I tell you 2 to the power of x equals 32, what would be the value of x? What do I do? So here's what we're going to have to do. We're going to have to, some of them can be solved without using technology, and we can write both sides of the equation as power of the same base. Which means John, what were you right now? What were you doing? Yeah, what were you doing on your calculator? So what did you do? 2 to the power of 4, right? 2 to the power of 6 to the power of 5. So you were trying to find an answer that gives you 32, right? As 2 to the power of something. Yeah? Okay, so if I write 32, did you find it, James?
No.
Try 2 to the power of 5. Yeah? So if I replace 32 with 2 to the power of 5, what you were doing, John, you were actually writing it to the same base. So instead of writing 32, you're finding what 2 to the power of what gives me that 32. Because now I can say, because I have the same base, I can say that x is equal to 5. Right? By making it the same base, then my power are equal to each other. Okay? So, and you are doing that without me teaching you this. Yes? Mm-hmm. So, what happened is, if a to the power of m is equal to a to the power of n, right? If I have the same base, then my exponents right away are equal to each other. As long as a is positive value and it's not equal to 1. Because the reason for that is if a is not equal to 1, if a is equal to 1, 1 to the power of 100 or 1 to the power of 10, it's going to be 1. So in 100 and 10, they're not equal to each other, right? So that's why a cannot be equal to 1. Okay? So, since 4 to the power of x and 4 to the power of 3 are both powers of 4, so my base is 4, the exponent must be equal. Then what I would say is, when 4 to the power of x equals to 4 to the power of 3, that means x equals to, I say that, drop the base, keep the exponent, right? So we just delete the base. So, sometimes it's easy, sometimes they're hard, right? It's not always that they're easy. So for the first one, if I have 5 to the power of x equals to 5 to the power of 6, what would my x equal to? X equals 6, right? Easy. example we just did now, I don't have a common base, but I have to make it a common base. Okay? So what we did is we used our calculator and we did try, guess, and check, right? And then we started plugging in values, 2 to the power of what? Right? And then we found that 2 to the power of 5 is equal to 32, right? So that means x equals to 5. How about 2 to the power of x equals to 1 half? What gives me 1 half? Remember that I have to make it to the same base, right? So what would my base have to be? 2. 2 to the power of what gives me 1 half? 2 to the power of what gives me 1 half? 2 to the power of what? What would I put a power here?
Negative 1, miss.
Negative 1, John, that's right. Why is it negative 1?
Because the slippage.
That's right. You remember, guys, one of the power rule is that if you have a negative 1 exponent, right, 2 to the power of negative 1, that's the same thing as 1 divided by 2 to the power of 1, yeah? So what is x equal to in this case?
Negative 1.
Remember, you're always thinking about what can I do to make it the same base. So if I have 2 to the power of x equals 1 over 4, what do you want to write as a base of what? As a base of 2. Can I change the 4 into a base of 2? So what would it be if I want to change it to a base of 2? 2 to the power of what gives me 4? 2 to the power of 2. Now, but that's not the same base, right? My base here is a half, I don't know. So what do I do to make it base 2? 2 to the power of negative 2, right? Because this is in the bottom. To make it a base of 2, it's going to be 2 to the power of negative 2, right? 2 to the power of negative 2 is the same thing as writing 1 over 2, right? What we learned about the negative exponent, you flip the base. So that means x equals negative 2. Probably the trickiest one are the ones with the flip, right? Okay. 7 to the power of 3x minus 4 equals to 49. What do you want to write 49 as a base of what? 7. 7 to the power of what gives me 49? 7 to the power of what gives me 49? 2. Plus 7 times 7. Okay, do I have the same base? So I can drop the base and keep my exponent, make my exponent equal to each other. Okay, so that means 3x minus 4 equals to 2. Do you guys agree with that?
Yes.
Okay, how can I solve for x?
Move it to the right side.
Move what to the right?
4 plus 4.
Move the 4 to the other side, that's right. So move the 4 here. 2 plus 4 is 6. Then divide by 3. So that's going to be 2. Okay? So I make my exponent equal to each other and I solve for the variable. Okay? Your job is to do F.